Hey there, welcome back. In the last video, we started exploring Excel's 4 data types. In that video, we looked at the first data type of the numbers data type, which are just things that you think of when you think of numbers: 2, -3, 2.7, things like that. We also looked at text strings, which are collections of symbols. So Excel, when we've got dog here, we humans we think of this as dog. Excel wouldn't think of this as dog. Excel would think of this as capital D, lowercase o, lowercase g, just like blocks in a printing press. That's what text strings are. In this video, we're going to look at the two slightly more mysterious data types, the ones that you see less often and are not hard to understand, but maybe not immediately obvious. So the first data type we're going to look at is the true/false or Boolean data type. And this is the data type that corresponds to yes or no calculations. And then we're going to look at the error data type, which tells us that something didn't work in our formula. So let's go look at true/falses, shall we? So a true/false value, also known as a Boolean value, is the type of value used by Excel to answer yes or no questions. Except in the universe of Excel, we don't say yes or no, or well, maybe we the humans do, but Excel only says true or false. So if you were to ask Excel a question like, "Hey Excel, do you want to go get lunch?" The answer would be true instead of yes, because Excel wouldn't say yes; it would say true instead. So an example of a formula that would produce a Boolean or a true/false data type is the number 7 greater than the number 5? Well, let's find out. So we're going to do equals 7 greater than 5. So this is the greater than symbol. If you remember your mathematics, this is basically it's going to ask the question: is this number over here greater than this number over here? And well, we know 7 is greater than 5, so when we hit enter, we get true, which is Excel's way of saying yes. Excel is saying yes, the number 7 is greater than the number 5, so it says true. See, we've got our little scales of justice here to indicate true. It's worth pointing out that this is kind of an unusual data type in that it only takes on these two values. So for numbers, there's millions and millions of numbers that the number data type can take on. Text strings, there's also millions and millions of different ways you could have text strings. But for the Boolean data type, it's only true or false. There's no maybe. Excel will never answer a question maybe. It will either answer true or it will answer false. Okay, so we've got our true here. We've asked the question: is 7 greater than 5? Let's change the question a little bit. Let's say is 7 greater than 8? And we know the answer is no, but Excel won't say yes or no. Excel will say false. False. That's Excel's way of saying no. Okay, so let's another type of question that might yield a Boolean value. Is the number 4 an odd number? Well, let's find out, shall we? Let's ask Excel. Hey Excel, equal sign. Is odd. So this is a function that you give it a number, and it will tell you if that number is odd or not. So we're saying is odd. Is the number 4 odd? Well, we know that the number 4 is even, so this should be no or false. And let's see if we hit enter. We get false. We get false, just like you expect. Now if we change it to the number 5, we get true. So that's another example of a Boolean or a true/false calculation. It produces a yes or no answer, which is recorded as either true or false. A slightly more complex version is: does the text string in C17 have more than 4 characters or symbols in it? Well, let's see. Let me change this. I'm gonna what do I want to call this? Let's call this Oregon. So we want to know, does this text string here have more than 4 characters or symbols in it? So to do that, we're going to have to do 2 things. I can't just click on is this greater than 4? Because this isn't a number right now. This is a text string, and you can't compare text. You can't compare text to a number. It doesn't make sense. But what I can do is here. Let's start by deleting this. We'll do this step by step. I'm going to type in len for len, which you saw in the last video. And what len is going to do, which is a shortened version of length, because it's, you don't want to type out the whole thing because you use this function a lot, so they just shorten it to len, but it means length. So if I highlight this area right here, this len function is going to look at this text string and tell me how many symbols are in the text string. So if we look, we can count manually. 1, 2, 3, 4, 5, 6. So it should produce 6. And if I hit F9, hey, I get 6. I'm going to hit Control Z to undo that. By the way, when I hit F9, it evaluates the thing that is highlighted. So when I hit F9, it's going to evaluate this thing right here. So F9, 6. Control Z to undo that. Okay, so now that we've got that number, we're going to say, hey, that number right there, is that more than 4? Is that more than 4? Well, and we know that when we highlight it and we hit F9, we get 6, and we know that 6 is greater than 4, so the answer should be true, and if I hit enter, it is. The answer is true. So you might be asking yourself, why? I can see how this variable exists, but when would you use these things? Well, you don't use them that often. You've probably not used them yourself yet, possibly. But you're going to use these guys later on when you've got a formula, and you want it to do different things in different situations. So you'll be able to put a test at the beginning of your formula, and you'll say, hey, go check this thing, and if the answer is yes, I want you to do this one thing, and if the answer is no, I want you to go do this other thing. So that's when you'll use true, false, or Boolean values. To put Booleans in formulas, they're sort of like numbers. You just type them in. So if I hit equals true, I just hit enter, and I get true. Now, if memory serves, if I type in true and I hit enter, it'll automatically capitalize it, because since I haven't put an apostrophe to let it know that I want this to be a text string, it looks at that and says, "Oh, I bet they're talking about the true, not the word, not the text string TRUE, but true as in the answer to a yes or no question." So I'm going to capitalize it and make it the value true. Just like with numbers, you have to be kind of careful. Equals text string true, and equals true are very, very different. And again, I shouldn't even really call this text string true. This is really a text string capital T, capital R, capital U, capital E. And this is true as in the answer yes to a yes or no question. So Excel understands true as the text string true is as these 4 characters, and understands this true as the answer to a yes or no question. Okay, well that's kind of it for Booleans. Let's move on to errors. Errors are Excel's way of telling you that something went wrong. Either something went wrong, or they can't give you an answer to the question that you're asking. So if I do equals 15 divided by 0, you can't divide a number by 0. So when I try and do it, it's going to say, hey, there's no answer to that, and this is a divide by 0 error. So it's got that little pound symbol and the exclamation mark and then div/0, divide by 0. It's a divide by 0 answer. I can also, if I were to try and add cats and dogs together, we all know that cats and dogs do not get along. So plus dog, and I hit enter, I get a value number, because the addition operator, which adds numbers together on either side of it, can't add text strings. It can only add numbers. So if this was 1 and this was 1, well then the answer would be 2, because I can add numbers together, but I can't add text strings together. So I get an error. Also, if I do say A1, which is a perfectly good cell reference, it references this cell right here, it's the cell A1. If I add that to A0, well, A0 doesn't exist anywhere. So this isn't really a reference. Excel is not going to know what this is. So if I hit enter, I'm going to get a name error, because it's trying to tell me, hey, somewhere in your formula, you're referring to something, and I don't know what it is. So generally, these errors, they're used most commonly to help you diagnose problems with your formula. They're used to let you know that something broke, something went wrong, you should go back and fix it. That's what they're going to be used for 90% of the time. And based on what they are, they'll sort of give you a hint as to what went wrong. So in this one, hey, you've named something improperly, or hey, I can't add these values together. This is the wrong value type. And in this case, hey, you can't divide by 0. But sometimes you will use errors to your advantage. You'll use them to sort of what you'll do is you'll take a function and you'll generally use it for something it wasn't intended for, to find an answer that is otherwise impossible to get. So, for example, oh, here, let's see, hold on, in the list, and I don't want this to say number. Is this, let's see, change this, text. By the way, I change these things a lot as I'm getting ready to make the video, so if there's errors in here, I'm sorry. I'm really trying to make it as clear as possible to people and make it as easy to understand as possible, not harder. Okay, so what I want to know, well, let's say I'm not going to know that. That's not going to be my question first off. My first question is not is this in this list of pies? So I've got my list of pies here, apple through key lime, and I want to know, is this in the list? I'm sorry, I don't want to know that. What I want to know is, where is it in the list? So the first question I'm going to ask is, where is peach in the list? So if I look, I've got my list here. I say, well, there's 1, there's 2, there's 3, there's 4. Hey, in the 4th position, there's peach. So I'm going to go over here, and I'm going to use, I don't want to do it manually. I want Excel to do it for me, because that's what Excel is good at. I'm going to use the match function. And what the match function does is you're gonna give it a text string or a number, and you're gonna say, hey, I'm gonna give you another bigger list of numbers or text strings, and I want you to tell me what position this first number or text string is in this collection of text strings. So this guy here corresponds to that, and F20 corresponds to that. So what match is asking right now is, where is peach in this list of pies? If this was ordered 1, 2, 3, 4, 5, which number would it be? Now we know the answer is 4, but we're going to have Excel tell us that. And we're going to enter 0 for right now for an exact match. I'll explain that later on when we actually get to the match function proper. But when I hit enter, I get the number 4, because peach is in the 1, 2, 3, 4, 4th position of this collection of cells. If I were to change this to pecan and hit enter, notice now that the answer is 2, because pecan is there in the 1, 2, second item in this list. How about this? I'm going to do the same thing as before. I'm going to equals match, and the text string I want to look up is raspberry, and I'm going to look for it in this collection of text strings. And once again, I want an exact match. And now the answer is NA. And the reason it's NA is because raspberry doesn't appear in this list. So Excel can't tell me where it appears in this list because it never appears. And so it's going to, rather than returning a number, which there is no number, it doesn't appear anywhere in the list, it's going to return this error, this NA error. It says, hey, it's not in the list. Now, if the thing that I really wanted to know was, where is it in the list? Well, then this is broken. But if the question that I wanted to know is it in the list at all? This has told me, no, it's not in the list. By using this formula, I've been able to find out that pecan is indeed in this list, while raspberry is not in the list. So that's an example of using an error to tell you something useful. Okay, so that's kind of it for errors. We've talked about this before, but I really want to drive it home because it's pretty important. You can use text strings, assuming you spelled them correctly. Text strings can look like numbers or true and false variables. So this is the number 100, and this is the text string number symbol 1, number symbol 0, number symbol 0. So they're very different. This is true, as in the answer yes to a yes or no question. This here is the text string. Capital T, capital R, capital U, capital E, right? So they're very different. This is June 14th. In fact, it's June 14th, 2014 to be specific. While this is just number symbol 1, number symbol 4, hyphen, capital J, U, lowercase u, and lowercase n. So these two things are very different. Now, why is this important? Why am I going on and on about this? Well, because at some point you're going to do something like this. You're going to do the sum of these guys here, and you're thinking to yourself, well, this is a pretty short list. I can kind of do this in my head. So 100 plus 20 is 120. 120 plus 5 is 125. So the answer should be 125, right? And I hit enter, and the answer is 105. Well, that's not right. And if this were a really long list, if this list were not 3 items, but I don't know, 3,000, and it spanned, you know, pages and pages and pages, you'd probably just say, okay, well, this sum function probably got the right answer for me. But maybe it didn't. And if you look here at the 20, you'll see that like this 100, well, that's the number 100, and this 5, that's the number 5. But this 20, oop, hold on. This 20 is actually the text string 2 and 0. So when sum adds all these cells together, it'll add this number, but it's going to skip this number. And for data that's generated by a computer, this isn't a problem. But when data is generated by hand, oftentimes people will actually enter numbers as text strings, usually accidentally, but it will cause your formulas to not work correctly. There is some good news, however. The good news is automatically Excel is going to use alignment to help you spot differences in data types. So here, these are all text strings, and if you notice, text is always aligned to the left. It's always hugging the left side of the cell, as opposed to numbers. Numbers, normally, by default, are going to be aligned to the right. They're always going to hug the right side of the cell. And Booleans, or true or false values, these are always aligned center. They don't. They're afraid of both sides. They're here in the middle. They're here in the middle hanging out. And errors, likewise, are always aligned center, or in the middle. And if you come over here, you can see that if you look at a column that's got a bunch of different data types in it, it'll be sort of easy to spot where different data types are. So, well, these, I don't even have to know what these are. Since they're aligned right, they're probably numbers. Since this is aligned left, it's probably a text string. Since these guys are aligned center, it's either a Boolean or an error. But I sort of, have an idea what they are. And here, more importantly, this is the case where you're going to use this all the time. If I look at this this column of what looks like text, I can very easily spot that, oh, well, this doesn't look like text because I know that text is aligned by default to the right, and this guy is aligned left, and this is also aligned left. So these are probably text strings. And if I look at it, oh, what did I do? Hold on, 4. If I look at it, it is indeed apostrophe 4. So this is the text string 4, and if I come down here, I've got the formula for the text string number symbol 7. You might see this with true or false or Boolean variables, but actually you probably will never ever see that. The place you're going to see it is here with numbers. You'll get a big giant list of numbers, and be able to spot where your problems are because they're aligned incorrectly. Although sometimes this can be overridden. So if say I get this list of values and I see that, oh, some of these are aligned incorrectly. I wonder why that is. Oh, who cares? I'm just going to go over here and do align right. Well, suddenly Excel was trying to be helpful, but it was all for naught because the default alignment has been overridden. So you still kind of have to watch out for it. Now, look, if you can see here, you've got that little green triangle. That's Excel giving you yet another warning saying, hey, I bet this is a number stored as text. Okay, so what do I really want you to take away from this? I mean, I've thrown a lot of information at you. You're probably not going to retain all of it, and that's okay. I don't really need you to retain all of it. There's a couple key things that I want you to retain, though. The first of which is numbers are basically just what you'd expect. You don't have to worry about those too much. If you see numbers, well, they behave as numbers have always behaved, which is handy. Text strings are the way a computer stores things that we think of as human language or English or words and sentences and paragraphs. And text strings are a series of symbols, kind of like printing press blocks or tiles from a certain family game that starts with an S. You might know what it is. And these symbols are they occur one after the other. So in this text string, it uses the symbols capital T, E, X, T, and it uses them in that order. So if you were to change the order of the symbols, it would be a different text string. Also, slightly less important, but still kind of meaningful, these true-false Boolean values, well, that's what Excel uses to answer yes or no questions. And at some point, you will start to use those to build internal logic into your formulas. And errors, well, that's the way that Excel gives you a general idea what did not go correctly in your formula. Why can't it give you an answer? And finally, this is very important. I don't know if you need to write this down, but maybe say it to yourself so you'll really remember it. Sometimes things that look like numbers are actually text strings. It's also true for Booleans. Sometimes things that look like true, false are actually just text strings. And this can actually turn into a big problem because this will cause most of your calculations to ignore them, which will produce the answer that is different than the answer that you want. Okay, well, I think that's good now. We've talked plenty about data types. I think we can sort of put this to rest for the time being. And I know this is kind of an abstract video, but even if you only retain maybe 10% of what I've said here, it's going to make Excel seem a lot less like a magical spell book whose behavior is powerful but capricious and impossible to understand. And it's going to seem more like a well-tuned machine whose behavior is clean, simple, and logical. Okay, well, once again, thank you for watching. Do stay tuned, and I will see you next video.